What if we could ask an AI to do more than just answer a question? What if we could ask it to map out the entire web of cause and effect for some of the world's biggest problems? Well, today, we're looking at a brand new system that does exactly that. It takes the chaos of all the information out there and turns it into some truly stunning, clear maps. Let's get into it.
So we're gonna start with a bit of a mystery here. We're looking at an artifact, something created by an AI that, honestly, at first glance, seems totally impossible.
Okay, take a look at this. This map lays out the collapse of the Indus Valley civilization from 5,000 years ago. But this isn't just a summary, it's a causal map. It's plotting the relationships between things like climate change, river droughts, and shifting trade networks. But here's the crazy part. A historian didn't make this, an AI did. So how in the world can a large language model, which is just supposed to predict the next word in a sentence, create something with this much structure and deep analytical insight?
Well, the short answer is it's not as simple as just asking the AI a single question. See, the raw knowledge inside these models is absolutely vast, but it's also, well, it's a total mess.
This quote from the research paper just hits the nail on the head. If you just ask an LLM about a really complex topic, you don't get a map. You get what they call a laundry list, just a bunch of isolated facts. There's no structure, no way to see the big picture of how all these little pieces actually connect to each other.
And that gets at a totally new kind of scientific challenge we're facing, right? Traditional science is all about going deep and narrow. You run controlled experiments that give you clean numerical data. But this new approach, it's about wrestling with the broad, sprawling knowledge that's buried in text and trying to pull out actual causal claims from this huge sea of information.
To solve this exact problem, researchers built a system they call Democritus. And you can think of it as a pipeline that's designed to take all that chaotic knowledge and, step by step, weave it into a coherent picture.
So let's walk through this. First, the AI breaks a huge subject down into smaller topics, kind of like an outline for a book. Then, for each of those topics, it starts asking and answering its own causal questions, like what causes a river drought? From there, the system boils the answers down into these simple little cause leads to effect statements. And this is where the magic happens. A really special layer organizes thousands of these tiny statements into a meaningful geometric structure. They call it a relational manifold. That's what lets the system see the bigger picture. And finally, that whole organized map gets stored as what's called a topo slice, a single, complete view of all that knowledge.
But here's the thing. There's a secret ingredient in that pipeline that makes all the difference. It's the one core innovation that stops the whole thing from just collapsing into a completely useless mess.
I mean, you might be thinking, can't you just take all those cause and effect statements and just connect the dots, right? What do you think happens if you try to do that?
You get this, a giant hairball. It's literally a tangle of thousands of connections. They're all, technically correct, but they are completely incomprehensible to a human being. All the information is in there, but there's absolutely no structure, no insight. It's pure chaos.
And this is the hero of our story, the geometric transformer. Instead of just looking at simple one-to-one links, this thing can actually see higher-order patterns, like how 3 or more ideas are connected. Think of it this way. It's not just connecting individual stars in the sky. It's finding the hidden constellations and even entire galaxies of related ideas. It's built to reveal the true underlying geometric shape of knowledge itself.
And this just shows you the incredible difference it makes. On the left, you've got that chaotic hairball of raw connections. And on the right, that's the result after the geometric transformer does its work. It takes that tangled mess and organizes it into these clear, meaningful clusters. It literally turns chaos into clarity. So now that we kind of get how this amazing system works, let's look at what it can actually do. Because the power and the sheer versatility of this new tool, well, it's pretty incredible when you apply it across different, really complex fields.
And just to give you a sense of scale, we are talking about a massive operation here. To build these maps, the system sifted through and processed over 90,000 different causal statements that were generated by the AI.
So what can you do with all that? Well, for one, you can map out economics. Here, it's untangling that incredibly complex web around the minimum wage, showing all the connections to employment, consumer spending, inflation, collective bargaining, and suddenly, what's usually a really heated political debate becomes a clear map of interconnected factors that we can actually study.
Or you can apply it to technology and the environment. This map here shows all the different drivers of electricity demand. It links everything from car traffic and data centers all the way to home insulation and climate change.
It's this holistic view that lets us see how even our daily choices connect to some of the biggest environmental challenges we face.
And this is amazing. It can even map an entire scientific field. This is a relational map for biology. And what's so cool is how the logical structure of the field just emerges visually. You've got anatomy over here, genetics over there, cardiology, neuroscience. They all find their natural place in this huge landscape. It's like having a Google Maps for a whole area of science.
So, what does all this mean for the future? Is this how we're going to solve all our problems from now on? Well, the researchers are actually really clear about the implications, and importantly, the limitations.
The first and most important thing to get is that these maps are not the final answer. This system is not here to replace scientists or controlled experiments, not at all.
Really, the best way to think about Democritus is as an incredibly powerful starting point. Its job is to create a structured map of potential ideas, a narrative that might reveal connections an expert could have missed. It's like having the world's most comprehensive literature review, giving domain experts this amazing bird's-eye view so they know exactly where to start digging deeper with their traditional research.
Which leaves us with a pretty fascinating thought. For the first time, we have a tool that can give us a high-level view of our most wicked problems, from climate change to economic policy to medical research. It's a tool that can help us see the whole system, not just the tiny individual parts. So the question isn't just what problem you would map first, it's what brand new discoveries are suddenly possible now that we can finally see the whole forest for the trees.